Now let's do question 3 on the midterm. So here are our 3 molecules, and the question is true and false, and we need to assign true or false to each of the statements. Okay, so the first one is compound X will react slower than benzene during an electrophilic aromatic substitution reaction. Okay, so benzene, as we all know, can undergo EAS, and it can do that in a fairly stable way. Sorry about that. And then this is not benzene, it has a substituent on it. So either this substituent will help us in another reaction, in another EAS, or it'll hinder our achievement of another EAS. So if we had an electron donating group, it would pull the electrons towards the benzene, and it would make the benzene more nucleophilic, and it would be much easier for it to attack an electrophile, which would speed up the substitution reaction. If we had an electron withdrawing group, it would pull electrons away, and then benzene would become less nucleophilic, and it would hinder the substitution reactions. So this right here is an electron donating group. It donates its electrons to the ring. That would make benzene more susceptible to electrophilic aromatic reactions, and that would make this statement false. So it would react faster instead if this was true. Okay, so the second one is there will be 8 resonance signals in the 13C NMR spectrum for compound X. All right, let's look at that. So whenever we're assigning NMR, we always need to look for symmetry, because if you don't, you're gonna mess up. Okay, so 13C NMR, we want to label the carbons. So there's 1, 2, 3, 4, 5, 6. Now, we want 7 and 8? No, we don't. We don't want 7 and 8 because of the symmetry. This is equivalent to 4, and this is equivalent to 5. It's just the rotation of the molecule can be oriented in either way, and these two are the exact same, and these two are also the exact same. So that's 6, not 8. And then we can assign this as false. The correct answer would be 6. Okay, so there would be 6 pi molecular orbitals drawn to describe the conjugated system in compound Y. Okay, so let's draw pi molecular orbitals. So there's 1, 2, 3, 4. By the way, we can draw these at any carbon where there is a pi bond, which is a double or a triple bond. And then there's a nitrogen here with lone pairs, and it also has a pi molecular orbital. So now the question is asking whether there are 6. So each one of these would have 1 electron, and the nitrogen would have 2 because of the lone pair. Sorry, that's very messy. Let me just get rid of these and put them here. So I count 6 electrons, but the question is asking, would there be 6 pi molecular orbitals? And for that, I only count 5 MOs. Or the 5 pi orbitals. That is a 5, not an S. Okay, so that would make this answer false. Okay, 4. Compound Y is a stronger base than diethylamine, which looks like, no, sorry, it's nitrogen, which looks like that. But the molecular formula here does not show diethylamine. That's dimethylamine, and that would be this. And it really doesn't matter whether the question is trying to ask us if Y is stronger than diethyl or dimethylamine, because it shows the same principle. So by stronger base, if something is a stronger base, it would mean that it is less stable. So a stronger base would want to react more fiercely than a weaker base, so it's less stable. It doesn't like where it's at, it wants to become a conjugate acid. So the statement is saying that Y is less stable than either of these two. It doesn't matter which one we're talking about. So on Y, let me just get rid of this. On Y, we have 1 electron, 2 electrons, 3, 4, and then, as I said before, there is 2 electrons. There are 2 electrons on the nitrogen because of the lone pair. That comes down to 6 electrons in total, which is 4, 1 plus 2, 1 being the N of the equation. So that would make this molecule aromatic, and as we, that's not an M, that is an M. Sorry, let me just clean that up. Aromatic. And as we know, aromatics are very stable, much more stable than that. So that means this is false. Okay, next, there will be 4 resonance signals in the 1H NMR spectrum for compound Z. So as soon as you see the mention of 1H, you should not wait to explicitly draw the hydrogens. So there's 1 on each because we do have double bonds and we only have space for 1 hydrogen. So 4 resonance signals. So I do count 4 hydrogens, but will there be 4 resonance signals? Once again, don't forget to look for symmetry. That is also one of the first things you should do when we're doing NMR. So because of symmetry, even though there are 4 hydrogens, these 2 are exactly the same, and these 2 are exactly the same, which means there would be 2 resonance signals. So if we're going to like correct these, this would be 5. This would be weaker. We're not asked to correct these, but just for understanding, this would be 2. Okay, last one is diene Z cannot participate in a Diels-Alder reaction. Okay. So the way I did this question on the midterm was probably not how the professor wants you to do it. But this is a molecule we've seen constantly in our examples for Diels-Alder reaction. This is like the bread and butter of the diene of Diels-Alder reactions. It has a cis conformation, which means that this and this are in cis. It has 2 pi molecular, or 2 pi bonds, and then the Diels-Alder bond would form over here. These ones will go, this one will make the sigma bond somewhere else, and this one would move over here. So this is, once again, the bread and butter of Diels-Alder dienes. But if you're not too sure, just scroll up real quick and look at this. Let me just erase all this from before. this looks, or at least this part of it, is pretty much almost exactly identical to the diene we had in question 3. So instead of being a 6 carbon ring, it's a 5 carbon ring, and that means this is a plausible diene, and it can undergo a Diels-Alder reaction. So the true answer would be can, but we want to label this as false. So all of these answers are false. And as for the bonus question, yeah, that's something I can't help you with. I don't even know. This is really weird. And yeah, that is the end of this, because I can't even do the bonus question.